Part 3 of the lecture will discuss the Cenozoic era, which means recent animals. In terms of paleogeography, we've developed the Alpine Himalayan chain in the Cenozoic, the Andes mountain range formed, the San Andreas fault system formed, the Basin and Range province in the western United States formed, the global climate cooled, and we had an ice age during the Pleistocene from 2.6 million years to 10,000 years ago. During the Eocene period of the Cenozoic, we have this paleogeographic reconstruction below, which looks more or less like the modern-day arrangement of Earth's continents, with a few distinctions. India had not yet collided with Asia, and Europe and Asia had not yet collided with one another to form a single landform. The Alpine Himalayan origin formed when the plate carrying Africa, India, and Australia collided with the plate carrying Asia. The Cordilleran, or North American, and Andean, or South American, origins are consequences of continuing convergent margin tectonics along the eastern coast of the Pacific Ocean. In this case, the Pacific Ocean is subducting or going underneath both continents in the Americas. The Basin and Range province in the western United States is a rift that began forming about 25 million years ago. The inset shows a cross-section along the red line, with red arrows showing the stretching direction, yellow arrows indicating the rotation of the crustal blocks. The Pleistocene Ice Age is when the world's climate generally cooled with intermittent warming periods. It began about 2.6 million years ago and continued up until the current interglacial period that we are experiencing on Earth today. In this example, glaciers in North America extended south of the current Great Lakes. Life evolved significantly in the Cenozoic era, which includes a recovery from the Cretaceous Paleogene extinction, the reappearance of forests and grasslands, the diversification of mammals and birds, the appearance of ape-like primates around 20 million years ago, the genus humans appearing 2.4 million years ago, and the Homo sapien species appearing around 500,000 years ago. Importantly, Neanderthals and Denisovans were extinct by around 25,000 years ago. Here's a picture of grasslands and some fauna that may have existed during the first appearance of grasslands in the Cenozoic. These include giant mammals instead of dinosaurs, which dominated the land. The human lineage evolved in the Cenozoic, with human-like primates such as Australopithecus on the right first appearing around 4 million years ago. As mentioned before, the human genus appeared around 2.4 million years ago, and our species, Homo sapiens, diverged from this genus, or diverged from others, around 500,000 years ago. In this figure, we see the change in the location of continents as a result of plate motions over the past 200 million years, from portions of the Mesozoic to our present state in the Cenozoic. An important concept in evolution is the concept of unidirectional change, which means that changes only happen once and don't repeat themselves. So in the case of the evolution of the Earth system, the Earth's interior differentiated to form a core, mantle, and crust, and this will not reoccur. The same thing happens in terms of the evolution of life. We have transformations that don't repeat. An example is the largest Mesozoic land animal was a reptile, whereas today the largest land animal is a mammal. Despite unidirectional change in general evolutionary terms, there are some cyclical changes that scientists have noticed over the years of studying plate tectonics. This includes the supercontinent cycle of rifting and convergence. So as the tectonic plates on Earth's surface subduct underneath one another and get recycled into Earth's mantle, the new production of crust allows for the movement of plates to get rearranged on Earth's surface. Over time, there have been periods on Earth's surface where all of the continental crust has been organized into one specific area and coalesced into supercontinents. Those supercontinents eventually rift and spread out into individual continents again, and this process repeats itself. Many scientists consider that we are now in a geologic age called the Anthropocene, where human activity is causing changes to Earth that may eventually be distinguishable in the geological record. An example shown below shows the amount of people on Earth has increased exponentially in the past 200 or 300 years as a result of technological advances and